As you know, many questions can be solved using data structure stack, and many problems can be solved using recursion. You may also know these two can be used interchangeably for some questions, such as a tree structure. Today, I'm going to use these two to solve a question. Convert prefix to postfix. Here is the question statement. Convert prefix to postfix using recursion. Plus times A, B divided by C, D. Convert to A, B times C, D divided by plus. First, let me introduce some notations in arithmetic and logical formulae and statement. Infix notation is a mathematical notation in which the operator is between operands, such as a plus sign in 2 plus 2. Here is an example of an infix expression. Prefix notation, also known as a normal Polish notation, NPN, is a mathematical notation in which operators precede their operands, such as plus, 3, 4. Here is an example. Postfix notation, also known as a reverse policy notation, RPN, is a mathematical notation in which operators follow their operands. For example, 3, 4 plus. An example of a postfix expression is like this. I have introduced stack data structure in my tutorial, Process Log with Stack. Stack is a last in first out data structure. It is commonly used in the evaluation of infix postfix expressions. Stack can also be used to convert infix expression to postfix, prefix to postfix. Here comes our first solution for the question using stack. The steps are: read the prefix expression in reverse order. If the symbol is an operand, push it into the stack. If the symbol is an operator, pop 2 operands from the stack. Create a string by concatenating the 2 operands and the operator of them. Push this string back to stack. Repeat the above steps until the finish of all symbols in prefix expression. I have also introduced recursion, or recursive programming, in tutorial Clean Folder Recursively and Build Hierarchy Tree. To recap, recursion is a method in which a function calls itself. As you may know, sometimes stack and recursion can be used interchangeably to solve the same problem. For example, we can use the recursion to do an in-order binary tree traversal. See the code here. Alternatively, we can use stack to do tree traversal without recursion. This solution is called Dfs Depth-First Search. The code is like this. Let's go back to our question. For this question, let's put parentheses for all operators. We see that each expression contains of following parts: operator, first operand, second operand. Each operand could be nested expression or a simple value. Here are the steps of the second solution using recursion. Prefix expression always start from operator. Let's remove it first. Find out the next symbol, whether it is an operator or a value. If it is an operator, we use recursion to process the nested expression. If it is a plain value, we return it as operand. We assemble operator and both operands in correct order. Operands come first, then operator. Repeat above steps until there is no more symbol in the expression. Now let's write the code. The first function is the stack solution. The input is the prefix expression as array of chars. The return is a postfix as string. At the beginning of the function is to define a stack. From the back of the expression, we check each symbol. If it is one of the operators, we take 2 operands out, concatenate them, and the operator push the new string back to stack. If it is not operator, that is operand, we need to push it to the stack. This is an utility function to check whether the character is an operator. Here is a function of the second solution using recursion. The input is an array list of a string for prefix expression. The output is an array list of a string as postfix. We use array list since it is easier for nested processing. We retrieve the first symbol in the array as operator, then get the two operands by running the same code twice. This is a place to use recursion to deal with nested expression. The last step is to put the operands and operator together as postfix expression. Let's run the code. When the prefix string is plus times a, b divided by c, d, when user stack, the result is a, b times c, d divided by plus. Using recursion, the return is a, b times c, d divided by plus. We can print this list as string. It is the same as stack's result. Let's try to run with another expression. Both results are the same too. This is O notation. Using stack, the time complexity is O(n). N is the length of the expression. The space complexity is O(n) for stack. Using recursion, the time complexity is O(n). N is the depth of the recursion. The space complexity is O(n) for recursion stack frame. That's it for convert prefix to postfix using two solutions. Please leave your comments below. I'm Vivian. Thank you for watching. Please like, share, and subscribe. I will talk to you soon.